Here are a couple of other examples. So assume A is set of cities and B is set of countries, and you define a relation to be where city A is the capital of country B. Then you would have these tuples in your relation. So these are some of the tuples in your relation, right? Riyadh in Saudi Arabia, Delhi in India, Washington and UC Islamabad in Pakistan. Second example is AB, where A divides B, and both A and B are integers. Okay, this is the divisibility relation. It defines those pairs which are where one divides the other. Okay, can you give me examples of some tuples which are in this relation? Oh, 6 3, no, not 6 3, 3 6. Yeah, so the divisor comes first. Okay, 2 4. Yeah. Okay. What? The first guy should be the divisor. Okay, so this thing reads A divides B. Okay, so the first thing needs to be the divisor. Okay, so for example, 1 and then any other integer would be a relation in here. Okay, all right. ABC. This is kind of a tuple that we already know. We have seen this before. ABC, where A square is equal to B square plus C square. Okay, these are Pythagoras triples. I should write C here as well. A B comma C. There's a typo there. Okay, a binary relation is a relation on a given set is a subset of A cross A. So sometimes when I have only one set, I would just say the relation on that set. Okay, and I would usually mean a binary relation on that set. Okay, so for example, if you have set 0 1 2 3, we can have an example of a relation as 0 0 1 1 2 2 and 3 3. This is the equality relation. Okay, you would have pairs of numbers which are actually equal to each other. Okay, so you would only get 0 0 1 1 2 2 and 3 3 in here. Similarly, the relation less than is given by this. Okay, and the relation greater than or equal to is given by this thing. Okay, so you can construct a relation by anything that is defined on pairs of things. Okay, so for example, since equality is defined on pairs of things, I can construct a relation based on equality. Less than equal to also defines a relation on pairs of things. Okay, greater than equal to also defines a relation on pairs. Okay, but remember that greater than equal to is different relation compared to greater than, just greater than. Okay, greater than में 0 0 1 1 2 2 और 3 3 नहीं होगा. Okay, are we good? Cool. Considering the following relations defined on the sets of reals and set of integers that are infinite. ऐसा यार आप लोग बाहर चले जाएं. Okay, so from reals to integers, here's a relation where it defines that x minus y का जो mod है, it should be less than or equal to 1. Okay, what does it say? It says that, in other words, x or y is are related if the distance between the real numbers is less than 1. Okay, less than or equal to 1. Right? Can you give me examples of numbers that are related by this relation? Yeah. 0 and 1. Yeah, 0 and 0. 0 and anything less than 1. Less than or equal to 1 are related. No? Oh, negative numbers भी होंगे, of course. अब R2 की बात करें, मैं R1 में इसकी बात कर रहा हूँ. Is it the same as this? मैं इसकी बात कर रहा हूँ. ये सबसे पहले जो हमने लिखा है. Okay? R की मैं बात कर रहा हूँ. Okay? So R में आपके पास क्या क्या होगा? R में you would get all pairs जिनका distance is at most 1. Okay? So 0 would be related with every number larger than equal to minus 1 and smaller than 1, smaller than or equal to 1, okay, and so on. R1. R1 defines a straight line in 2 dimensions. Okay, so R1 says that these are pairs of real numbers where A is equal to B. Okay, what kind of line is this? Yeah, it's y is equal to x. It's the diagonal line. Okay, this defines a ball of radius 1 in 3 dimensions, and this defines, what does it define? Pairs of number A is in Z and B is in R. Cool. It defines a set of vertical lines, infinite set of vertical lines. Are these relations clear to all of you? No? Yes? No? Questions? Yeah, Hanan.
Last slide में वो greater than or less than or equal to
हाँ हाँ
क्या difference?
Okay, so I gave you a set, okay, 0 1 2 3. अब इसके ऊपर जो less than वाला relation होगा, it would pick a pair of numbers and see if the first one is smaller than the second one. If it is, I would put it in the relation. If it's not, I will not. Okay, so I'll pick, for example, 0 1. Since 0 is less than 1, 0 1 would be in my relation. If I pick 2 1, 2 is not less than 1, so 2 1 won't be in my relation. Okay, so that's the less than relation. Similarly, if you pick greater than or equal to, I would again pick every possible pair of numbers, and I will check if the condition is true on those pairs. Okay, for each pair the condition is true, I'll put it in my relation. If it's not, I'll throw it away. Okay, make sense? Good. Now let's come to this part. Okay, now ask questions on this slide. Yeah. Sorry, what? This one? Okay, so this thing is defined on, since this is an infinite relation, again I'm trying to give you a different flavor of relation. It's defined on the real line, okay, real numbers. So what I do is I pick a number 0, and then I'll pick another number, and I'll check if their absolute difference is less than or equal to a 1 or not. Okay, if it is less than or equal to 1, I'll put it in my relation, and if it's not, I'll not. Okay, so what I just said is, okay, this would be valid for everything. For 0, all of these numbers would be 0 related to. Okay, so you would have 0x where x is greater than or equal to -1, or x is less than or equal to 1. Okay, similarly, if I pick, for example, 0.5, what kind of x would I have? What would 0.5 be related to in this relation? कहाँ पे? और आना चाहिए ना? So अगर ये वाली condition true है तो भी हमारा relation बनेगा. अगर ये condition true है तो भी I will have that pair. So 0 and -0.5 is a valid pair, and 0 and 0.5 is also a valid pair. Right? इन दोनों का जो absolute difference है, it's less than or equal to 1. इन दोनों का भी absolute difference less than or equal to 1 है.
लेकिन हम उसमें 2 भी ले सकते हैं, 3 भी ले सकते हैं.
नहीं ले सकते. So if you pick 0 and 2, this is not a valid pair. कहाँ पे? वो यहाँ पे कह रहे हो? If I pick 2 here, तो फिर that's not the. Oh, yeah, you're right. You're right. I absolutely good. You caught me. So I need to say something else. I need to say that this is greater than or equal to 0, and less than or equal to 1, or the other way around. Okay. So I need to say this. So numbers in this range and odd numbers in this range are all valid for me. Okay. Good. Good point. Cool. Nice. Okay, good catch. ठीक है. Okay, questions? People ask questions. I know there are questions on this slide because I spent next to slide explaining this slide. Do you guys understand this? Okay, so since there are pairs and they are real numbers, they define points in 2 dimension. Okay, and they're only valid where a is equal to b, which means that I'll get a diagonal line. Okay, how about this one? Do you guys know what a ball is in 3 dimension? So I don't have an example of a. I have some in my office, but if you look at this is a golf ball. It's not a football. Okay, what that means is that it also includes the inside. There's also something inside. Okay, उसको technically math में हम लोग ball कहते हैं. Okay, so for example, this thing is a circle. Okay, this thing with everything inside is the ball in 2 dimension. Okay, it's a ball in R2. Okay, this is a circle. Similarly, if you pick a golf ball, that's a ball in 3 dimension. Okay, but if you pick a football, that's actually a sphere in 3 dimension. Okay, because it just is the surface. There's nothing inside. Okay, the inside is air. Okay, are we good? Okay, so over here I'm saying that if you pick 3 numbers and sum of their squares is less than or equal to 1, I would get a ball in 3 dimension. I would get a golf ball in 3 dimension of radius 1. Okay, इसका radius 1 होगा. All right. Okay, that's the definition of ball in 3 dimension. Okay, cool. What else do I want to say? So, yeah, okay. So the last one I'll explain in a moment. But can anyone see why last one is true? What I'm saying is pick an integer and pick a real number. Okay, all those pairs define something that's my relation. Okay, and what I'm saying is that it's just vertical lines, infinite number of vertical lines. Okay, so for example, if I pick a to be 0, I would get a vertical line that's y-axis. Okay. If I pick my a to be 1, I would get a vertical line which is x is equal to 1, right? Okay, so you'll get infinite vertical lines. Okay, that's defined by this relation. Let's see them in picture. So this is the first one. Okay, it's the vertical line which is defined by a equals b. Straightforward, right? This is the second one. Again, this includes everything inside. Okay, all right. By the way, yeah.
यहाँ पे A, B और C equal हो सकते हैं?
Of course हो सकते हैं, क्यों नहीं हो सकते? Why not? So they need not be. Okay, I'm not asking that they should be equal, but if they're allowed to be equal. Okay, they're allowed to be equal, but they need not be. Okay, it's all right if they are not. Okay, for most of the points they won't be. Okay, good. Again, this includes everything inside the ball. Okay. Question: if I wanted a relation for just 3-dimensional sphere, what would my relation look like? What's the relation that defines the surface of the ball, or just sphere in 3 dimension? Give me a definition in terms of relations. Do you understand my question? So I said that this relation defines a ball, okay? And when I said ball, I mean a golf ball, okay? I want to define a football. How would I define a football using relations?
Equal to 0. A plus B square
You said a plus b square is
A square plus B square is equal to C square.
almost no. So I want my football to be of radius 1. Okay. बोलो क्या कह रहे हो?
A square plus B square is equal to 1.
No.
A square
Okay.
plus B square plus C square.
Yeah, a square plus b square plus c square is equal to 1. Okay, that's the definition of the sphere. Okay, less than gives me everything that's inside. Okay, equal to gives me everything. By the way, if you are gonna tell you a kind of non-intuitive thing. If you are 4-dimensional being, you can actually go inside the sphere and check whether there is something inside or not. Okay? I mean, we show this in something called algebraic topology, that if you have a 3-dimensional ball, and you don't know whether this is a golf ball or football, and you want to check whether it's a golf ball or football, as a 3-dimensional being, you have to cut the ball, you have to punch the surface of the ball, right? If you were someone who is in 4-dimensional, you don't need to. You can directly go inside from the 4th dimension, check whether it's a football or a golf ball. And so it's kind of intuitively why this is true. Let me show you. Intuitively look at this thing. This is a 2-dimensional football, right? If you are a 2-dimensional being, you have no way of knowing that whether this is air or the ball itself. To figure out whether this is air or the ball itself, you have to punch through this boundary. Okay? But as a 3-dimensional being, I can look from the 3rd dimension that this is empty here. Okay? The same is true about the 3rd-dimensional sphere. That if I give you a golf ball or a football, you can check from the 4th dimension whether there's something inside or not. You can go directly in the center. All right, one more question for you guys. I want to represent this thing in 4 dimension, and this thing is called a cube. Okay, you guys are familiar with this thing. So so this is 0 0 0. Okay, the center of this cube is 0 0 0, and it's a unit cube, so length of each side is 1. Okay, you understand this structure? It's a structure that lies at the center 0 0 0 of 3 dimension, and उसकी हर side की length 1 है. Okay, I want to represent this structure as a relation. How would I do that?
A square plus A square plus D square plus A square is equal to 1.
I'm gonna give you about 60 seconds to figure this out, and if you do, I'm gonna. Everyone understands the problem? Let me make sure that everyone understands the problem. So for now, what we are doing is we are doing an exercise of representing things, sets actually, as relations. Okay, this is a set of points which lie inside this cube. Okay, and I want to represent all of them as a relation. Okay, these are all subsets of 3 dimension, right? So it's the relation that I'm looking for is basically subset of this Cartesian product. है ना? But what is it exactly? How can I write it down like this? Okay, that's the question I'm asking you. Okay. A cube equals to 1. So see, you need to restrict all of the dimensions, right? This should be obvious. There's no special direction here. This is kind of a symmetric body. If it's symmetric, then there is no special dimension, right? Same as ball or cube. Okay, कोई special dimension नहीं है. किसी एक तरफ से stretch हुआ होता ना, so that would have been, you would think some of the dimensions are more important than the other, right? It's symmetric. So whatever restriction you put, you need to put it on all 3 dimensions. Sorry, what? A minus B minus C equals 0.
Is equal to 1.
Hold on a second, let me one guess at a time. I need to figure it out. What does that look like? I'm just trying. It's not the answer, but I'm trying to figure out what does that look like. No, it's nothing like this thing. Yeah, because see, you can pick A to be really large, right, and B to be very small, right? Us case में you would have a point, as far as from 0 you want, right? If you say that my condition is A minus B minus C should be 0, I can pick A to be very large and B to be very small, right? And I would get a point that's very far away, right? That won't lie in this thing. Yeah. Do you have answer for any one of them? I'm looking for answer for any one of them. Okay. एक तो ये है कि you whole cube और एक just the surface of the cube. Okay. So give me answer for any one of them. A cube plus A. That's absolutely wrong, man. Absolutely wrong, right? For two reasons. One, I told you that there is no special direction. है ना? आप सिर्फ A को ले रहे हैं ना, सिर्फ एक direction को ले रहे हैं. That does not make sense. No, man. I don't think so. What are you guys up to? Close the door, man. Kick them out. अब्दुर्राफ़े कोई अंदर नहीं आना चाहिए अब.
A raised to power 8 is equal to 1.
You are going as far away as possible from. Try to. So once again, sorry.
A into B into C is equal to 1.
Again, wrong, and it's very obvious to see, because you can pick A to be really large, you can pick A to be 60 and B to be 1 over 60, right? You don't want that, right? You want all of your direction, all of your dimensions are limited. Okay, let me try to make this simple for you. How about I keep this as my 0 0? Okay, forget about this. So this is my origin. Okay, this is kind of a simple, I mean it's the same thing but translated a bit. So now this point would be 1 1 and 1, right, because all of your lengths are 1. There's nothing special about A. Okay, so whatever restriction you put on A, you have to put on B or C as well.
अगर 3 डायमेंशन होंगे और वो की वजह से बराबर होंगे, तीनों A नहीं होंगे, A.
Oh, okay, so you are saying that this is A. This is what you're saying, okay?
A cube volume
Sure, I don't care about that. I'm just trying to think कि आप किस तरफ जा रहे हैं. This is quite simple actually. Yeah. All right. Okay. I'm not. You guys are getting much harder questions than I gave you, but this is quite simple. Equals to what?
A equals to B equals to C equals to.
Okay. Here's the answer, and it's kind of so simple. A is between 1 and 0. B is between 1 and 0. C is between 1 and 0. That's it. That's the only condition that you have. That's what you're looking for. I mean, isn't it simple that if you're looking at points, the only condition is none of the directions are more than 1. Okay? All right, let's move on. This was a freebie that you missed. Okay, so this is the figure for the third relation, which is that A is an integer and B is real numbers, and these are the vertical lines. You should be able to get horizontal lines and this mesh thing. Okay.